Good morning, good evening, good afternoon to people around the world. This is Martin Hubel, your ever-present host of the DB2Night show. And today we have show number Z135, and we have, again, a very valued repeat guest, Maryela Weihrauch from the IBM SVL lab. And we have a great topic today on using profiles to control and monitor application context. So let me get through the race through the introduction here to get to the really good stuff instead of just me. So with that, I will move on and talk about our links again. Hashtag DB2Night, people follow that. And we also announce the shows on DB2L on the IDAA list server. That works well. And we have our replays available on YouTube as well as in our replay blog where you can download the PDF as well. Where our speakers now are quite happy to share their material with you. Okay, there's our disclaimer, all the usual stuff. We respect copyrights, things are being recorded, and we'll make things available, and they all belong to DBI at the end of the day. Our other quick announcements, our upcoming shows. I finally have completed the entire slate of shows for the spring. We've got our next show for DB2 LUW is on the 14th of April, and that's UDF's Beyond the Basics with Phil Nelson. That should probably have some applicability to people on the mainframe as well. Phil is bilingual, as we like to say. He works on both Z and LUW. He's done that for a good 20 years in terms of working on both platforms. Then we have Dale McInnes talking about DB2 Always On architecture on May 12th. And on June 9th, we have Callisto Zuzart of the Toronto lab talking about the machine learning optimizer. John Hornibrook asked about it last week, and it seems it's about time for people to have an update on that. On the Z side, next month is Cheryl Larson, a longtime friend of the show and a longtime friend of mine, going back to the early days of IDAA back in 1989 when we were both there. The other guy that was there at the time in 1989 and has spoken at so many IDAGs is Dave Belke, and he'll be joining us in May 12th to update his DB2 Java performance best practices presentation. And then we'll finish off the year with Sonia Kamaswaran of the IBM Silicon Valley lab talking about transformation of the user experience in DB2Z. So it's a pretty good, great lineup of speakers, and we look forward to having you participate. As always, the founding sponsor of the DB2Night show is DBI Software, and they have DB2 LUW tools that are used in many shops around the world, and they also now support SQL Server with their tools as well. Congratulations to David Churn of AWG. He's getting an Amazon gift certificate. I believe he already did get it. And our sponsors are DBI and yours truly, Martin Hubel Consulting, Inc. With that in mind, let's just get through these polls. We have standard ones we like to ask, and which is, what's your highest version of DB2 in production? See if we got any version 13 people out there. Have you got to be on 5.10 or so to be able to go to version 13? Most people have voted quickly, so I'll close that and share the results. Seems we have everybody on version 12 today. That's a good thing. I'm not sure we would see anybody on 13 just yet, but there you go. Hide that and move on. What DBMSs are you using in your shop? You get to choose any number of answers here. This is a relatively basic question, but it's nice to see who, what people are running. Whoops, I got to hit the button to launch it. That's it. Those buttons, those are tricky. And again, not too much of a surprise here. Got people voted quickly. Thank you for that, and sharing the results. Well, you're surprised, not a surprise that everybody on the call today is DB2 for Z, but got an awful lot of other DBMSs off mainframe as well. Hide that. And the last question, which is pertinent for today, is just asking if you are looking into DB2 version 13 functionality. And again, people are voting quickly, and we're up to the answer right now. So I'll close that off and share that. And we see people are looking at it, are planning to start soon. And that's just great. Okay, with that in mind, let's move along. And Maryela, we'll let you take it over. You've got your webcam still on. You might choose to leave it on if you like, if we want people to see your smiling face, or you can turn it off and save some bandwidth for folks, depending on how things are running.
Yeah.
So
I will turn it off to save some bandwidth.
Okay. And I'm making a presenter just now. We should see that coming up shortly. As always, as you start presenting, I'll watch the question queue and break in as needed to share those. I'll mute myself in the meantime, so if a dog walks by in the street, you won't hear my little dogs barking at it. They're normally very quiet, but so please take it away. Thanks.
Thank you, Martin, for this nice introduction. So for you who do not know me, my name is Maryela Weihrauch. I'm an IBM Distinguished Engineer. My focus is on C data and AI, not just DB2 any longer, but also the portfolio around DB2 for COS. In today's presentation, I want to discuss the usage of profiles to monitor and control DB2 application context. To me, this is very important functionality to protect your application execution. Like, think about this, one interesting safety net. So now I need to, oh, okay, so the typical disclaimer you can read in your own time. So let's go into the topics I want to cover today. So first of all, I want to give you an overview about profile monitoring, what the purpose is, and then go through how to use it, some sample definition in the profile tables, and also characteristics of the profile table. It may be confusing a little bit confusing in the beginning, but when you tried a couple of examples, I think it's very straightforward. The main focus is actually on use cases, when you should use entries in the profile tables to influence the behavior of your application. And then last but not least, I like to show you how the profile table was extended in DB213 to add another use case, but this time not just for distributed application, but actually also for local application. So let's go into what the profile monitoring is. Actually, the initial introduction of the profile tables was in DB2 version 9, so it's now forever, especially with the speed of IT today. And it was mostly used to influence query characteristics, SQL, especially for complex SQL. The usage was significantly extended in DB210 to address a pain point that became very common, and that is the adoption of distributed applications in application servers connecting back to DB2 COS, especially driven around Java application adoption. WebSphere is just one example. The problem applies pretty much to all web application servers that have some form of a connection pool. So the problem that came around is, first of all, the separation of duties, that no longer the DB2 sysproc or the DBA influenced how application connect to DB2, but actually the administrator of the web application server. And it turned out that the connection pool definition in the application servers were very seldom correctly defined. And because the interest between a sysproc and web application server was different, this became actually a pretty big pain point for the DB2 administrators that had to manage those environments. So initially, the resources that were managed were the number of connections, the number of threads, and the timeout values. Before the introduction of the profile table, those three values could only be defined on a DB2 system level, and it would apply to all distributed application equally. And that was not good enough, because this created a couple of problem scenarios. Based on the power of that functionality, the new use cases were added to the profile tables, which were special registers and DB2 defined global variables. And as I mentioned, in DB213, we actually start to support also local threads for another use case. So it is really about two focus areas. One is to narrow down the scope of definition from a CPOM, which is system level, to an application scope. And we will go in a second in what the application scope means. And the second focus is that you could influence the application characteristics without changing the applications. For example, rerouting an SQL statement to an analytics accelerator. So you see, it's pretty, the usage is in many areas, and it's really to help to protect the workloads in DB2, and B, to enable new functionality that you otherwise could not as easily adopt them. So let's look into a couple of use cases, and I will have example later on. So the first one was actually the most motivating one, to prevent a workload with either true denial of service attack, or I would call it application code errors that simulated a denial of service attack characteristics. And the most common one was actually in Java applications, that they coded exceptions incorrectly, and caused, in the case of an exception, caused to create new connections to DB2 in a tight loop. Just finish this. Give me 1 second to remove this. Okay. So the next pain point was that, especially in large environments, a lot of different DB2 driver, DB2 Connect driver levels were installed, and the DB2 team never really had a tool to force the distributed application server and individual user to migrate to even at least a supported level. So that can also be influenced. The third use case is, and that came because of the web application servers actually over-define their connection pool settings, and potentially in a workload peak could push out also critical applications. So with this definition, you can actually make sure that critical applications from critical distributed application get their fair share on threads to execute the workloads. And as I mentioned before, you know, influencing the characteristics by setting special registers or global variables is really to make changes to the application characteristics without actually change the code of the application. And as for a non-distributed use case, and that was the first use case, you could actually use a profile table to anticipate access paths in tests by modeling specific characteristics that would sometimes be key characteristics for access path selections. So hopefully with this intro already, I have you highly motivated to actually look into the system profile monitoring capabilities if you are not already using it, or maybe you review your settings and extend the usage. How you exploit this for distributed clients, you actually do it in a two-step way. The first step is that you have to define what your distributed application means to DB2. And there are different means how you can do it, either through IP addresses, through authorization IDs, roles, or even driver levels. So we will go into detail how you can define it. And then, of course, after you define your application scope, then you would go into the second table and define the values for this profile. And this could be reducing CPOMs to an application level, like for the max dbet number of threads, or setting special registers or global variables. So, Martin, if you have questions, do you have a chat or customers or participants?
I actually have there's a question tool built in where people write in their questions. And right now we don't have any questions just yet.
Okay, perfect.
But things are looking.
Yeah, I just opened the chat. Okay.
Thank you.
Yeah, so please feel free to ask questions, and if I see them, I definitely will address them. So, as I said, there are system profile monitors is implemented through two catalog tables. One is DSN profile table, which defines profile, which represents your application scope. So it could be yeah, we will go through the details in the example. And the second table is the DSN profile attributes table, which then defines the criteria on which one the profile is actually managed. And it has a couple of entries. One is the monitoring function type. So if you want to manage connections or threads or special registers, so that goes into the keyword column. And then the second attribute one, you tell DB2 if you want to trigger a warning or if you want to trigger an exception. And then the third column, which is attribute 2, will define the threshold when a warning or when an exception is executed. Very important, and that evolved over the lifetime of DB2. So if you are in lower maintenance level or even DB2 version 11, you may have to check it out. That initially you would start the profile table over using the start profile command, and you would have to do it on each member if you are in a data sharing group. We introduced that through the maintenance stream, that whatever definition was used is actually remembered across a DDF stop start. And the latest one is update to this functionality is that now you can actually set a CPOM profile underscore auto start to tell DB2 to start the profile tables at the time DB2 is started. So if you are in back level maintenance mode, please pay attention that those functionalities were introduced step by step. But if you are in DB2 version 12 and we don't have anyone with 13 yet, then having the CPOM set, I think, is the most common usage from an operational perspective. So let's go into some examples how to do the definition of profile table entries. So you see in the top table 3 color codes. One is orange, one is purple, a dark purple, and a light purple. Or so each of these color set or those columns define one set of workload identifications. So in one row, you cannot define a role and auth ID as well as a location. So they are distinct. So you can have one entry where a workload is described by, or an application is described by an auth ID, and you could have a second entry where an application is defined by a set of IP addresses or a location name. And both may affect and map to the same settings, but so you can actually have multiple rows in the profile table that apply to a single application instance, but they cannot be defined in one row. Okay, and then in the second table, the DSN profile attributes table, you map to the profile ID so that the application character or application scope is mapped to a keyword. And of course, you can have multiple keywords defined for a single profile entry. And then, as I said, in attribute 1 column, you give what happens if it needs to be a warning or an exception. And then in attribute 2, you provide the threshold. And I would like to point out the example that is marked as blue, where you see that the number of connections is monitored for a specific profile, which is identified by this location test.svl.ibm.com. And you see that if we have 45 connections, DB2 would start to issue a warning message. And if it reached the threshold of 90, it would actually cut off any new connection requests. So until, of course, until the number of existing connections for this applications go below the threshold. So I hope this example makes it clear how you would define it. So let's go into more details on how to define the profile, especially for the location name. So of course, with thousands of applications being in your environment, potentially, you do not want to have every single application defined in the profile tables. This would be an administrative nightmare. Therefore, wildcarding is actually really important. You could use the star for the wildcarding of the auth ID and product ID. And you see an example that if you use a temp star as an auth ID, it would match to any auth ID that begins with temp, including the temp with nothing following as well. Same applies to the product ID columns. So you could actually address a profile for a specific driver type. For example, for all Java JCC driver, and act based on that. The most complicated one, from my perspective, is the location column, and unfortunately, that is also the mostly used one. So let's go in a little more detail how this looks. I walk you through a couple of examples. The first one is you define an IP version 4 address, so with the 4 entries, and you see that the IP, the subnet would start with 9.30.222, but any IP address that is in the subnet would actually be affected by this profile. Same, very similar for the IPv6 address or address. I think the majority of IP configuration moved to IPv6 now, just because of the sheer size. So you could do similar wildcarding for IPv6. And then the third one is if you want to have an entry that applies to every single distributed connection, then you would just type in a 000. Okay, maybe a little detail. You see the slash after, like /24 or /64. This represents the number of bits in the address. So you could even reduce the subnet to even more granular scopes than just the leading definitions. Okay. So this slide explains it a little bit more detail how the subnetting in IP addresses is defined. I don't want to go into more details, but I want you to have this information. As I said, this is the most common way to define the scope of a distributed application. So let's now go into the rollback attribute, actually it's a clarification of the exception attribute, because if you just type in exception, you get a specific characteristic of of the application. So the thread is aborted and the connection is terminated. And if you are familiar with, for example, sysplex workload balancing in the driver, you know that this would trigger, if a connection is terminated, it triggers a different behavior than if the connection is still around. So if the connection is terminated, the application actually has no connection to DB2 any longer. So DB2 would show up as unavailable, or if the connection is handled in a connection pool without sysplex workload balancing, then that would show up as a stale connection, which triggers exception handling, which is in quite frequently coded incorrectly. So you don't really just want to have the exception behavior. You actually want to think about the rollback option as a specific characteristic. So if you add, or if you define in an attribute one column exception underscore rollback, then the thread is still aborted, but the connection remains inactive, which means the application still sees the connection to DB2 and it's just in an inactive state, so ready to take new work. Of course, you have nothing pending from a previous unit of work. This was all cleaned up by the abortion. But the value is that the application does not have to go through the code to re-establish a connection, or if the connection is handled in a connection pool, it would not go in a stale connection and may trigger weird behavior in the connection pool management. One other topic to remember, because this question comes up quite often, is the idle thread timeout value. In the past, I saw in DB2 installations that have idle thread timeout set to 0, meaning it's not applicable because they have one misbehaving application that opens a unit of work and never commits, or does not commit for a long period of time. So idle thread timeout does not apply to distributed threads that meet the criteria for the monitor idle thread profile. So it means now you could set idle thread timeout to the default or even lower. It shouldn't be very much higher than the default in my perspective. I think this is a good default for the CPOM. And then you would, for this one misbehaving application, you would have an application scope definition, and then you would set in the profile table attribute, you would actually set, for example, a 0 for monitor idle threads criteria for that application. Okay, so this way, all the applications would, you would have the safety net of the thread management for all the applications except the one that has this incorrect, or how should I say it, which is coded in a way that it's not a good citizen in an enterprise environment. Let's say it's this way. Okay. So a little more on the rollback option, and this is where the attribute 2 comes in. So just remember, if the distributed thread qualifies for this entry and it's idle for longer than the value you define, and it could be 0, then the following characteristics happen, and you need to be aware of these characteristics. So if data changes have been made on this unit of work and were not committed, Then, as I mentioned, with rollback attributes, the thread is aborted and the dbat is back in, is pooled, so it's ready to be reused. Also, of course, all the database changes are rolled back. That's what the rollback attribute defines. And the connection goes into an inactive state. If data changes have not been made, that still the thread is aborted and dbats are pooled and the connections go into an inactive state. If a thread is aborted and any resources are still on this or were saved on this thread, for example, a held cursor or cap dynamic statements, DGTT and log locators, or I think the 4 typical examples. Of course, if you abort the thread, all of this information are gone. I mean, DB2 completely cleans up the thread. So from an application perspective, they will be lost. So you may need to be aware of this characteristic. So now let's go into the first use case, or how to set global variables. And actually it should mean global variables and special registers. The 2 most common use cases are for the transparent archiving functionalities that we introduced in version 11 and extended in version 12. And the analytics accelerator routing this for distributed application that of course only applies if you have an accelerator. And this would apply starting starting in version 11 actually. So the purpose here is really that you do not need to make application changes to get this behavior. And a good example is you have, for example, a reporting server, for example, Cognos, connecting to DB2, and because the majority of the requests coming from a Cognos server or can be tabloid or any, and reporting tool, the assumption is that the majority of the queries are complex, so you want to route them to the analytics accelerator by definition, and that could be accomplished through this profile table. So how do you do this? And first of all, you have to be on DB212, function level 500 or higher. And you could set in the profile tables the following definitions. So those are global variables or also special registers. So it's the one here, get archive, move to archive, temporal, logical, transaction, and transaction time. They would all be global variables. And in the DSN profile attributes table, you define the keyword global variable or special register, and then you define actually the set statement as you would code it in your application. And what DB2 does, it actually takes this statement and executes it before the first SQL statement is executed. So keep in mind the selection criteria for defining the profiles and how a matching profile or matching attribute is selected is unchanged. But now you not just have a criteria, you actually execute a state and a set statement. So you can run into additional error scenarios. And the first one is that you type in a set statement that is not supported. So you would actually go you would actually get a message saying rejected, unsupported set statement, and the other value would be rejected. It's an invalid global variable setting. So what is important, and that question may be raised very quickly, what is the precedence for the global variables? How do they apply? So of course, if the application has explicit set statements, that takes precedence. There's no question about it. Then the next one would be the set statements that are defined in the profile table if it matches to this application. And then, of course, you could have either defaults that are defined in the system. So set in the application, then what is defined in the profile table, and then the global defaults will take effect, or the CPOM settings if we have CPOMs. So from an authorization perspective, just keep in mind that the authorization model, so first of all, maybe I need to clarify it. Special registers, of course, do not have an authorization model tied to them. Everyone can set a special register. Global variables is different. Global variables have an authorization model. So you can actually authorize a user to use a global variable, and if you don't have that, then you cannot use it. So it's important to remember that this authorization model for setting global variables does not apply to the global variables set through the profile table, because they are actually executed under the system ID and not under within an application. So actually the user who inserts the rows into the profile table and profile attributes tables needs to have the authorization to set those global variables. It's kind of the same concept as with packages, that the user who binds the package needs to have the authority on the base table and not the user who actually calls the package. It's the separation. So you need to be aware of that and this only applies to global variables, not to special registers. So just one more comment on message granularity. That was also step by step improved or extended, because initially the information was that a profile triggered a warning or an exception, which is very nice protection, but it doesn't really help to fix the problem. So you need to have application information to actually contact your application teams to help resolve the problem, or contact them and enforce a specific behavior that you want to see. So the solution is that you have actually higher diag levels to get additional information. So it's LUW ID, and then you can, with the LUW ID, you get additional information about applications. In order to get this, so you actually have to type in attribute 1 that you want to have a diag level of 3, which is the highest one. So there is a diag level 1, diag level 2, and diag level 3 gives you the most complete information, not just about that the profile row was triggered, but also application information that enables you to fix it. So let's go now in a couple of use cases. And actually this use case triggered for me to put this presentation together and get renewed focus on it. This is actually a very recent example. What happens is, and that's a true example, that in an environment that was a very high TCP connection counts, and this was triggered to actually a connection pool tool that wasn't very sophisticated. And it seems to be common. I saw it now in more than one space. So what happens is that in this connection pooling, the connection is actually established to DB2. It's used one, it stays there idle, but it's never reused. It's coming, if a new request comes in, then the connection, it's establishing a new connection and uses it. So what you see from a DB2 perspective is you have this idle DB2 connection, and this is now connections from the application server to DDF. It's not number of threads. So all of those connections are inactive, so they do not take any resources in DB2. And of course, the idle thread timeout doesn't apply to it either, because there's no DB2. So it's truly the connection from the application server to DDF, where we can have a large number, no question about it, but it's getting excessive if the connection pool logic is keeping it around and never reusing it, and it doesn't make sense anyway. But in this specific characteristics, it stayed around for half an hour, and then they got cleaned up, and then it's built up again. So what it did is, or what triggered actually this almost denial of service attack was the customer or the user upgraded to a new COS version, which triggered that some of the control blocks became bigger than before, and it actually hit a memory limit in COS. So the whole COS system came down. And not because of DB2, actually because of TCP/IP, but it doesn't matter really, because the cause was actually this humongous amount of idle DB2 connections that were sitting there and were not be used. So what happened is that those old idle connections are essentially blocking new work when they hit the max connection limit. And of course, the sysprocs were very nice. They increased this level more and more. So they removed the gate to stop new connections. But from a DB2 perspective, you cannot influence, there is no way to close connections. They have to be closed by the application server. So this is a problem that needs to be addressed by the application server. But what can be done, and this was our recommendation, to protect DB2, because in this specific case, the whole COS error came down, which was pretty severe. So we said, you know exactly which application uses outdated connection pool software. So just put a profile table in, an entry in, so you can actually monitor it, issue a warning, and so you see the green line in the table below. So we said, okay, set it to 90 to start warnings, and actually cut it off by if they reach 180 connections, which means in essence that this connection, this application can not go beyond those number of connections without cleaning up before. But it does not affect the other connection, and it does not affect the entire system. So this is really a way to protect DB2 and the COS system from those misbehaving application. And this time it was not even the application, it was connection pooling software that triggered this behavior. The way out is actually to improve the connection pool logic, either by switching to a different connection pool vendor or improving it. I mean, none of the IBM connection pool code has this behavior, but there's also software out there as well. So this was a really eye-opening experience. Of course, it created a lot of escalation, etc., where I said, you know, we should advocate profile capabilities more, because it's not just reflecting back on an outage and see, it's also those problems come first back to DB2, and the image of DB2 is impacted as well. Okay, so the next example, and I have to check for time. I have to hurry up now. The next example is
actually,
new driver level.
You can go till quarter after the hour without too many problems. That would be just fine.
Okay, great.
Thank you.
Great, thank you. So migration to new driver level. So what you could do is put the product ID of the, I would recommend at least the driver level, the lowest driver level that is in service, and execute. And again, you have a way to say, I give a warning. You know, you may have this warning for 6 months and informs application server owners that this client needs to be upgraded. But eventually, if they don't listen and not act on it, you could actually turn the warning into an exception, and then it would prevent those old driver level to connect to DB2. So it's a decision from you when you're ready to enforce it, but it can be enforced. Okay. And now I go to the last use case, and this was introduced in DB213, which is a consequence of an evolution. So the story behind is that, you know, if you have your packages bound with release, commit, everything is freed up at commit, and I think John Campbell was a strong advocate to commit frequently. So that would be great behavior for maximum scalability and concurrency. Starting with DB210, we supported more memory. So with the introduction of 64-bit addressing, we actually advocated more that you should keep information in memory to reduce CPU consumption. And actually, it's also improving performance, because if it's readily available in memory, you also save quite a lot of processing to get it in and out, and so on. Of course, then the response was that if I bind my packages with release deallocate, then I have problems with breaking in. So also break in with utilities and so were addressed, but the remaining part is actually the DBA activity to do DDL. And this behavior or this use case in DB213 allows you to use the profile tables and a couple of new settings to break into a workload or into packages that were defined with release deallocate to get this critical DDL updates going. So the new special register is current log timeout, and there is also a new built-in global variable deadlock resolution priority. And a new keyword was introduced for the profile tables, that means release package. So let me walk you quickly through how this works. So you have packages that were bound with release deallocate. and you want to do an order table on the objects used by the package, and of course the DBA never has a chance to break in, because a commit doesn't free the packages. So what you could do now is actually have an entry in the profile table where you define the new characteristics, activate those. So those are actually the entries. So you would define a profile ID, the collection ID would deallocate. So it would apply to all packages that are bound with release deallocate. You activate the profile, and then you have a keyword release package. So meaning that if a package was is active with the allocate, then if this hits, that this profile hits, then the package is actually released at commit. So it's somewhat similar from a characteristics as we had with the distributed application where you could actually, DB2 could force the release option of commit, even you would bind your packages with the allocator. Okay, and you could define if this characteristics apply to distributed application, local application, or to both. So this is the first keyword that applies to local application except the SQL tuning parameters. So how would this look? You make the profile definition, you start a profile, and now you can actually do the order of the table, and it would actually go through. Just one comment on the deadlock resolution priority. This is a new global variable, and from an application perspective, you could only set it up to 254. So you could define now with this deadlock resolution priority if one application wins over another in general terms, but in this specific use case, you could actually set the value to 255, which cannot be set from an application perspective, and therefore the DBA would always win, would always have a higher priority. But of course, you could do it more granular. You could say, okay, if those really, really important packages are used, then you cannot break in, but then you would need to set a different priority. So the priority gives you a way to define who is the loser in respect to a deadlock resolution or a conflict resolution, as in this case. Okay. And yeah, I think I covered this already. So actually, I'm almost on time. So just to sum it up, you see the impact you can have with the profile table is actually quite wide now. I see it as a really important capability to not just influence workload behavior, but actually also protect your DB2 system from misbehaving application. You should review those use cases, evaluate how they are applicable in your environment. And I like to encourage you to actually use it because it may save you a lot of headache, as in this one example that I explained. And then just be aware as you migrate to DB213, there is this extended profile functionality that allows you to break in with DDL even if the packages are all bound with release deallocate. So with this, Martin, I'm done, and I want to hand over to you.
Okay.
I don't know if there were any additional questions.
I have a question now from Michael, and it's more of a comment, I think, but it's might be worth discussing. His point is, would be nice if you could have the PRD ID under JCC 03 so that it would handle everything below that version.
Okay, that's I take this with me. That's
Okay.
it will simplify the management of some levels. Yep.
Okay, and with that, let me take back control, and so I can do my wrap up here and ask our big final polling question that we like to ask, which is, there we are. Last question we have at the end of every show is, did you learn anything today? And we're getting people to vote quickly. Thanks for those people that stuck to the bitter end. And out of that, the majority of almost all our audience have voted, and 100% of people learned something, which is absolutely fantastic and kind of expected for a brand new topic like this. We had a good sized audience today, so that's great. So with that in mind, once again, as always, Maryela, we always like to have you on the show, and thanks again for your valuable information. And I hope to see you at a conference soon. I don't think I'm going to make Philadelphia, but I'm still considering whether or not I'm going to make Prague. But
yeah, I will be in Philadelphia. Yep.
Yeah. Okay. Well, take good care. I'll start the music. Thank you once again, and thank everyone for attending. And we'll see you in a couple of more weeks back on the DB2Night show for Phil Nelson and UDFs. Take care, and bye-bye.
Bye.
Bye-bye.